All right, so this is going on page 158, once we just talk about it quickly. So here are pictures of cones that get sliced by the planes that actually create your conic sections. Remember, these are called double-napped cones here. And then if you look on the inside, it has all the things. These were at the top of all your first day of notes that we had, but it's all in one place. So you have notes that you can look back at that has details, but to kind of sum up everything, it's all right there in one place. What I did want to look at, though I don't want you to write this on there, is when we talked about the eccentricity, and it's like how circular something is, right? So if your eccentricity, which is just the ratio of what to what? C over A. Okay, so your eccentricity, so let's write it right here, I guess. Eccentricity, that is E equals the ratio of C over A. And it's basically how circular or how far from circular your conic section is. So for a circle, E is equal to 0. For an ellipse, E is between 0 and 1. For a parabola, E equals 1. And for a hyperbola, E is greater than 1. Okay, so the larger the E value becomes, the larger that ratio it is, then the farther the figure is from a circle. So if it's just a little bit more than 1, it's kind of a skinnier hyperbola. If it's a whole lot greater than 1, then it's going to be one of those really fat ones. And you can kind of tell from an ellipse, too, the closer to 0 it is, the more circular it is, and then the skinnier and more stretched it is, it's going to be closer to 1. Okay? Make sense? You may not care. I think it's kind of interesting that, that's what your eye doctor is doing. And there's lots of other applications to this stuff that unfortunately we don't always have a whole lot of time to talk about, but that's that. So that's just a reference thing for you to stick in your ISN, so you can just go ahead and glue it in, and there it is, and there you go.